In this video, we're going to use normal probability plots to assess normality. This particular problem, we're given some measurements and we're ultimately asked, is it reasonable to conclude that the sample data come from a population that is normally distributed? The first part of this problem, we're asked to construct a normal probability plot, and we're going to do that using StatCrunch. So let's open up our data in StatCrunch. And we can find the normal probability plot underneath graph, and it is called the QQ plot. So we'll select our variables, select our column called var1. And let's go ahead and turn on the correlation statistic. And one more option that I see here is on the y-axis. I see it says expected z-score. So just so I'm looking at the exact same type of graph, I'm going to turn on this option, normal quantiles on y-axis. When I click compute, I should have a graph that looks very similar to the options that I see, but it's not exactly the same. Let me move some stuff out of the way here. And it may just be because of the scale that's used here on these graphs. I see that most of them, the x-axis is scaled from a minimum of 3 to 6.5, except for this one goes from 4 to 7.5. All of them have y-axis that are scaled from negative 2.5 to 2.5. So I want to create the same scale. And to do that, I can come down here to the menu option at the bottom, and I can have my x-axis minimum be 3 and maximum be 6.5. And I could do the same thing for the, for the y-axis. The minimum is negative 2.5 and the maximum is positive 2.5. And then if I just kind of make it literally about the same size on the screen, I should be looking at something very similar to my options here. So I just want to pick the best choice. And it appears that choice B looks to be the best choice. Now, using the correlation coefficient of the normal probability plot, is it reasonable to conclude that the population is normally distributed? Well, that's going to be based on this table of critical values. So let's open that up. In the measurements table that we had earlier, we were looking at 27 measurements. That's stated right up here at the top. So for a sample size of 27, I don't see exactly how many or that exact sample size right here in my chart, but I do know that the critical value is somewhere between 0.959 and 0.960. And if I look back at my correlation statistic over here, I had something less, which is 0.924. So what does that mean? That means ultimately, no, it's not reasonable to conclude that this population was normally distributed. And that's because the correlation between the expected z-scores and the observed data was 0.924, which does not exceed the critical value. And notice here it does tell us use n equals 30. And I believe, again, that critical value for 30 was 0.960. Therefore, it is not reasonable to conclude that the sample data come from a population that is normally distributed.